All right, we're going to look at solving inequalities today. So learning targets, solve inequalities, and then also be able to write in that interval notation that we've done. Also recall when multiplying or dividing with inequalities, both sides of the inequality sign by a negative number, you got to switch the inequality sign. So if you're dividing by a negative, you got to turn the inequality sign the other way. All right, let's try some out here. So if we're going to solve this one, just like you want to solve it just like you would a equal sign problem. So here, let's try to get our x's on the same side. Since we only have one number here, let's keep that there. Let's move the 9x to the other side by subtracting. Subtracting, don't ever have to worry about anything when you're adding or subtracting. Keep the sign the same way. So now we got negative 6x on this side, 4 on this side. Next thing we would do to solve is divide by negative 6 to get that x by itself. So that cancels out. Here we just have x. On the other side now we're going to have negative 4/6, or that would simplify to negative 2/3. However, we did divide by a negative here, so this is one of those instances we do need to switch the direction of the inequality sign. So the numbers that are described by this inequality would be all the numbers greater than negative 2/3. They also want us to write this in that interval notation. So writing this in interval notation, negative 2/3 would be the smallest thing. We're looking at all the numbers bigger, so all the numbers out to infinity. Remember, with infinity or negative infinity, it's always parentheses. With the negative 2, we're not including that, so that would be parentheses on that side as well. All right, next one, solve this inequality and again write it in interval notation. On this one, it looks like we have numbers on both sides, so let's get those away from our x's. Let's start by subtracting a 6. So now we got negative 2x left on the left. On the right side, we have 8. Now let's divide by the number in front of x to get rid of that. So divide by negative 2. So now we just have x remaining on the left side. On the right side, if we divide that, that's negative 4. We did divide by a negative. We do need to switch the direction of the inequality sign again. So that's the inequality that describes this in interval notation. That means negative 4 is our smallest thing. It's all the numbers greater than, so all the numbers up to infinity. Infinity always gets a parentheses. On this one, though, we want to go bracket on the negative 4 because we are including the point negative 4. If you have fractions, what you want to do is multiply by reciprocal, or in this case, like the number in the denominator, because we want that the number in front of x to be 1. So the number in this one that we would multiply to make that 1 would be negative 4. If we multiply by negative 4 times negative 1/4, the two negatives would make it positive. The 4's would cancel. Only thing left would be 1. So that's what we need to multiply by. On the other side, though, that also means this side needs to get multiplied by negative 4. So here, on the left now, we just have x. On the right side, multiply that out. So if you got 32 times negative 4, that's going to be negative 128. And then we divided by a negative, or multiplied by a negative in this case, so then we do need to switch the inequality sign again. So there's our inequality. In interval notation, this one's similar to our last one. Negative 128 is the smallest thing to infinity, including that negative 128, so bracket there. If you got x's and numbers on both sides, up to you how you want to go through and solve that. Add or subtract numbers here. Maybe we could start by adding 6. So now we got 5x is greater than 7x plus 34. So now let's get our x's together, subtract 7x. And now we got negative 2x is greater than 34. Last step, we got divide. We're dividing by a negative, so we got to again switch those around here. So sign switches the other way. 34 divided by negative 2 is negative 17. That's our inequality. In boundary notation, now this one's less than negative 17. So we're going to head towards negative infinity on this one, with negative 17 being our larger thing. We're not including negative 17, so we should have parentheses there. All right, if you get one of these ones that are that have inequalities on symbols on both, and you got stuff in the middle, you have to do it to both sides of the inequality sign. We're trying to get x in the middle, just only x. So if we add 18, not only do we need to add 18 here, we also need to add 18 to the other side of that inequality sign, so both sides. So now in the middle, that's going to be 0, and we got just only 5x there now. On the right side, if we add those numbers, we get 17. On the left side, if we add those numbers, we get 16. So now we want that 5 out of there. Now to get that, we got to divide by 5. So again, not only divide by 5 here, but also over here. In the middle now, that's 1, so we only have only x. We divided by a positive, so we don't need to do anything with switching the signs. So the sign should stay the same. So on the right side, we got 17 fifths, fifths, not 15ths. And on the right side, or left side there, we got 16 15ths. What is this one going to end up looking like here? Well, let's interpret what the graph's saying. This is all the stuff less than 17 fifths. So if we had a graph here, I'll just go by fifths. So we'll say this is 14 fifths, 15 fifths, 16 fifths, 17 fifths, 18 fifths. Less than 17 fifths, that would look something like that. Now let's look at the other one here. If we're looking at this part, that means 16 fifths is greater than x, or if we were to switch these two things around, so because that's usually the way we see it with x on the left, the inequality sign's pointing at the x. So this is saying all the numbers less than 16 fifths and equal to, it should be that. So how do we describe all those points together? Well, that would be, we could just say that together as, looks like this is all the numbers less than 17 fifths going this way. Now we're both these graphs are including all these numbers, so together we could just say that this is all the numbers less than 17 fifths. So in boundary or interval notation, that would be negative infinity to 17 fifths, not including 17 fifths or negative infinity. On this one, solve this linear equality and express it in intervaltation and graph on the number line. Okay, so here on this one, you got a couple things being added, and it's being less than 1 here. First thing we're going to need to do if we got to add and subtract those is to get a common denominator. So try to pick out a number we know that 6, 4, and 3 all go into. I think 12 would probably be our best bet here. So to make this denominator 12, we would times by 2, but that means at the top we're going to have to times by 2. And the second one, we're going to want to multiply that by 3. So the top we're going to have to times by 3. On the last one, we're going to want to multiply this one by 4. So that means the top we're going to multiply by 4. So after doing all that, all these denominators are going to now be 12. So we can have one big common denominator here of 12. But we got to do our distributing now. So if we distribute a 2 there, we're going to have 2x plus 10. Plus, now we're distributing a 3 to both of these. So plus 9x minus 12. And then finally distribute on the last one. Now the last one is a minus, so we got to distribute a negative 4 to both of those. So if we do negative 4 times 2, that's negative 8x. Negative 4 times positive 1 is a negative 4. And this is all still less than 1. Okay, to solve that now that we just have one denominator, we can get that to the other side by timesing both sides by 12 here. So that'll get rid of that. There's also some like terms we now can combine up here. So you got 2x plus 9 is 11, minus 8 is 3x. Let's combine our constant terms. 10 minus 12 is negative 2, minus 4 more is negative 6. And on the right side we have 12. We don't need to flip the inequality sign because we multiplied by a positive, not a negative. Now add 6 and divide by 3. We're dividing by a positive, so we don't need to flip the sign. X being less than 6 would be the answer. If you were graphing that one, wherever 6 is, it'd be all the numbers less than that, not including 6. In our interval notation, that'd be negative infinity to 6, not including it, so we'd use parentheses. All right, your turn. Try one similar to the one we just did. You need to start by getting a common denominator. All right, let's see how you did here. Our common denominator between 3, 11, and 5, smallest thing is just multiplying them together and getting 165 here. So that first one is going to need to get multiplied by both 5 and 11, or 55. So you're going to have to distribute a 55 to both on top, giving us this stuff. The 11 needs the 3 and the 5, so you got times by 15, distribute to both. You should end up with that. The final one, 5, is going to need the 3 and 11, so times by 33. Make sure on this one it's a minus. You got to distribute that negative sign too, so make sure you had plus 99 on there. Next now, we have to combine all these like terms, so you should end up with this when you do that. Also, to get rid of that 165, we want to multiply both sides by that, giving us 660. To finish solving that now, add 71, and then divide by negative 7. Dividing, you do have to flip the inequality sign around here, and I don't believe that 7 goes into that, so we'd end up that x is greater than negative 731 over 7 for our answer. In boundary notation or interval notation, that would be our smaller thing. We're not including that. To infinity would be the interval for that.